Hello, in our last Google Slides lesson 3.4, we worked with compound interest and used an online calculator. This time in 3.7, and it'll take a few days, we are going to use a scientific calculator. So please pull one out or find one online. You're going to need to make sure that you can use the caret button because we're going to be taking things to an exponent and we're going to need parentheses.
Welcome to Unit 3.7 on calculating interest. In this video, we will explore the concepts and calculations related to both simple and compound interest. Our learning targets for this unit include recognizing how simple interest is a linear equation and how compound interest is associated with exponential growth. We will also learn how to calculate compound interest and compare how compounding frequency affects the investment value. Consider the two graphs showing savings over time. Which graph would you prefer to represent your savings and why? Think about how your decision might change if the orange graph involved a greater risk of losing your savings. This reflection leads us to a key concept in finance. With investments, there is a greater risk of losing your money when there is an opportunity for a greater gain. This is summarized as greater the gain, the greater the risk, or bigger the risk, the bigger the reward or loss. Before diving into calculations, let's review the order of operations using PEMDAS, parentheses, exponents, multiplication, division, addition, and subtraction. Remember, we need to follow the order to calculate properly. In problem 2, we have 51 plus 4 squared. First, solve the parentheses. 1 plus 4 equals 5. Next, apply the exponent. 5 squared equals 25. Finally, multiply. 50 times 25 equals 1,250. Now try problems 3, 4, and 5. In number 3, remember to divide 4 by 2 before adding 1. Next, we will look at the difference between simple and compound interest. After watching the relevant videos, answer the questions. What is simple interest? What is compound interest? And what is the main difference between them? Simple interest is represented by a linear equation and graph written as y equals mx plus b. This graph increases at a constant rate. Compound interest is represented by an exponential equation and graph. Notice how the graph starts out flat, then becomes very steep over time as the interest compounds. Examples of linear growth include saving money in a piggy bank. Examples of exponential growth include savings accounts and mutual funds, where interest is earned on both the original amount and past interest. Let's review the variables used for calculating compound interest. A is the amount in the account. P is the principal amount. R is the annual interest rate as a decimal. N is the number of times interest is applied per year, and T is the time in years. Now let's practice calculating compound interest. If we invest $500 for 5 years at 3%, what is the value if compounded annually? Use the provided formula and table to fill in the variables and find the total amount. For our second practice problem, we will use the same investment of $500 for 5 years at 3%. This time, find the value if the investment is compounded daily. Remember that compounding daily means N will be much larger than annually. Compare the results from the daily and annual compounding scenarios. Which one earned the most money? Reflect on why that specific scenario resulted in higher earnings. Let's try another practice problem. If we invest $1,500 for 5 years at 2%, find the investment value if compounded weekly. Fill in the variables P, R, N, and T, then solve for A. For our final practice, we keep the principal at $1,500 for 5 years and compounded weekly, but increase the interest rate to 4%. Compare the results to the previous weekly scenario to see the impact of a higher rate. Finally, review your practice problems. Which principal amount, $1,000 or $1,500, earned the most money, and why? If choosing an investment strategy, what specific components, principal, rate, or compounding frequency, would you prioritize to earn the most money? Explain your choice.